Okay, let's think about the heart for a second. That amazing muscle just beating away. But what happens when things go wrong with its structure?
Yeah, it's vital, isn't it? And today we're diving into one specific condition, arrhythmogenic right vessel, ventricular cardiomyopathy,
Mm.
ARVC for short.
ARVC. Right. And the plan is to really focus in, pull out the absolute must-know facts from the revision notes we've got, like a shortcut to the essentials.
Exactly. Think high yield. We're going to boil it down, make it super clear, easy to remember, whether you're, prepping for an exam or just want to understand it better.
Perfect. So mission accepted. Let's get the core info on ARVC. Where do we start? What is it, fundamentally?
Well, at its core, ARVC is a disease of the heart muscle itself, a primary cardiomyopathy.
Okay.
And the really key thing, the hallmark feature, is this progressive replacement. The muscle tissue of the right ventricle, specifically, gets replaced by fatty and fibro-fatty tissue.
So the right ventricle muscle turns into fat and scar tissue. Is that the idea?
That's pretty much it. Imagine the muscle cells disappearing and being replaced by fat and fibrosis over time. It changes the structure of that heart chamber quite dramatically.
Okay, I can see how that would cause problems. Healthy muscle gets replaced. That can't be good for pumping.
Precisely.
Yeah.
It affects the heart's ability to contract properly and, crucially, its electrical stability, too.
Ah, the electrical side. Now, what causes this replacement? Is it something people are born with?
Often, yes. There's a strong genetic link. We're usually talking about mutations in genes responsible for desmosomes.
Desmosomes, remind me.
Think of them like molecular rivets or maybe strong glue. They hold the heart muscle cells tightly together.
Okay, rivets or glue. Got it.
So if you have a mutation in one of the genes for these desmosomes, the glue is faulty. The heart muscle cells, particularly in the right ventricle under stress, can detach.
And when they detach, the body fills the gap with fat and scar tissue.
That seems to be the process, yeah. It's like a wound healing response gone wrong, leading to that fatty replacement instead of healthy muscle repair.
Wow. Faulty rivets, tissue replacement. And does this run in families?
Very much so.
Right.
It's typically inherited in an autosomal dominant pattern, meaning you only need to inherit one copy of the faulty gene from either parent to potentially develop the condition. So seeing it in multiple generations isn't uncommon.
Right. Okay, so it's genetic, affects the right ventricle structure. How would you see this electrically on an ECG, for instance?
Good question. The ECG can show some characteristic changes. One of the most common ones is T-wave inversion.
T-wave inversion. Where, specifically?
Especially in the leads that look at the right side of the heart, V1, V2, V3, the right precordial leads. The T-wave normally shows the ventricle resetting electrically, so an inversion there is a red flag.
Okay, T-wave inversion in the right leads. That's a key finding. Anything else?
Yes, there's another sign, though it's a bit less common. It's called the Epsilon wave.
Epsilon wave. What's that?
It's this little small positive deflection, a sort of electrical wiggle that you can sometimes see right at the very end of the QRS complex, but before the T-wave starts.
A little wiggle at the end of the QRS?
Yeah. It represents delayed electrical activation in parts of the right ventricle. It's quite specific for ARVC when you see it, but maybe only present in, say, 50% of patients, give or take.
So T-wave inversion is more common, epsilon wave is more specific, but seen less often.
Exactly.
Is there a way to remember those ECG findings easily, like a mnemonic?
We could use TEA, T for T-wave inversion, E for epsilon wave, A for ARVC.
TA for ARVC. I like it. Simple. Okay, so these structural and electrical changes, what's the actual impact on the person? What are the risks?
Well, the big concern is arrhythmias, abnormal heart rhythms. Because that fatty, scarred tissue doesn't conduct electricity properly, it can create short circuits or areas of slow conduction.
Leading to dangerous rhythms.
Potentially, yes. Ventricular tachycardia, ventricular fibrillation.
Yeah.
These can be life-threatening. And tragically, this puts individuals with ARVC at a higher risk of sudden cardiac death.
That's really serious. So diagnosis must be crucial. You mentioned the ECG. What else is involved? I know we're keeping it high yield, but just briefly.
Right. Briefly, the ECG is key.
Yeah.
But doctors also use imaging like echocardiograms or perhaps more definitively cardiac MRI scans to actually see the structural changes in the right ventricle. The thinning walls, the fatty infiltration, how well it's pumping.
Okay, imaging to see the structure.
Yeah.
Got it. And just to place ARVC, how does it compare to other heart muscle conditions? Our notes mention HOCM briefly.
Yes, hypertrophic obstructive cardiomyopathy, HOCM. It's also a primary cardiomyopathy, but it's quite different.
How so?
The fundamental difference is this. HOCM is about the heart muscle becoming too thick. Usually the septum, the wall between the ventricles, thickens asymmetrically. Think muscle overgrowth.
Whereas ARVC is about muscle being replaced by fat.
Exactly. HOCM is thickening, often linked to mutations in genes like myosin heavy chain. ARVC is fatty replacement, linked to those desmosomal genes. Both can cause serious issues, like sudden death, particularly HOCM in young athletes, but the underlying pathology is totally different.
Thickening versus replacement, a really important distinction. Okay, so let's recap ARVC quickly then.
Sure. Key things for ARVC. It's the right ventricle. You get fatty and fibro-fatty replacement of the muscle. It's often genetic due to desmosomal mutations.
Autosomal dominant, usually.
Right. And on the ECG, look for T-wave inversion in the right leads and maybe that specific Epsilon wave. Remember TE for ARVC.
And the big worry is arrhythmias and the risk of sudden cardiac death.
Precisely. That's the high-yield summary.
That really crystallizes it. Understanding those core pieces is vital.
Absolutely. And if you listening want to delve deeper, maybe for exam revision or just more detail, definitely check out pastmsra.com. And there's also freemsra.com. Great resources there.
Excellent recommendation. So pass them at daserish.com and freemsra.com. And hopefully this deep dive gave you that clear, essential understanding of ARVC. It shows how breaking down even complex conditions into key features can really help lock them in. Thanks for joining us.